Okay, in this video, I'm going to be talking about power factor, and power factor is a bad thing, and it's caused mainly by inductors, but it causes the voltage and the current to fall out of phase from each other. So when we have our current out of phase and our voltage out of phase, what power factor causes is these two phases that may have originally been the same to change phases. And this is a problem because it's going to be less efficient, and we don't want these two to be on there because it changes our power factor number, and power factor number leads to some of these other problems. So power factor comes from the idea that it's dealing with complex power. So if power factor is the difference between voltage and current, then it's also the difference in some of the voltages. I guess the main idea of power factor, if you're thinking about it logically, it's the difference in phase from current to voltage, but you're going to calculate it using apparent and real power, or like the total power and the resistive power, the total voltage, resistant voltage, or the total and the resistance. So all three of these triangles are showing the same thing, but it's just the difference between the total and the real, and the power factor is the cosine of this angle. So if we're doing cosine, it's the adjacent over the hypotenuse, and it's VR over VT, real over apparent, or resistance over impedance. And that's what I tried to show here, that you can calculate it using any of these three. And power factor equals the cosine of the angle, and this angle is the difference in the current and voltage and phase. So I guess that's the relationship I was trying to talk about here before, is that this angle is the difference in their phases, but power factor is the cosine of that angle to solve for these. So you have power factor and you have the angle that the power factor adjusts those two. I guess those are two separate things. Okay, and why power factor is important is because the power factor of 0 is the most ideal, because that would mean that your voltage and your current are on the same phase and they're working together. And if we change our power equation from some of our other lessons, we get the equation I equals P over V cosine of theta using this. It's not as important how we got there, but it just helps explain what power factor causes. So a higher power factor means that we have to have more current. If we were to increase this, it's going to increase this. And that means that if you have more current, you need to have bigger wires and bigger lines to transfer, which is going to cost more. You're going to have more current loss if you're dealing with more current. And that if you also have more current, then you need a bigger machine to produce that current. So big ideas out of this is that this angle is the phase difference between your current and voltage. Power factor is the cosine of that angle, and you use the total over the resistance.